Hey class, Mr. M here with a homework video for you to watch. This one is a concept that you learned last year in Algebra 1, but it's one we haven't used in a very long time, and it's one that's going to become very important when we talk about circles on the coordinate plane, which becomes quite interesting, as we'll see. And that concept is called completing the square. So if you don't know what that is, that's why I'm here to help remind you, completing the square. Okay, so here's a sample problem from Algebra 1, solved by completing the square. And we have a trinomial here, meaning there are three terms. And you may remember, looking at a problem like this, you have to factor this thing. You've got to think about what numbers multiply to give you 49, but then add or subtract to give you 8. Well, 49, that's 7 and 7, but 7 and 7 don't combine to give me 8. They combine to give me 14 or 0, so that doesn't work. So how do you factor this thing? You're sort of at a loss. And that's where completing the square comes in handy. It's a good method to make something factorable, basically. So how do you begin? You begin, the first step, and I'll write these over here, is to isolate the x terms. Get the x's by themselves. So right now that means that pesky 49 needs to be obliterated. So we're not going to totally get rid of it. We're just going to move it to the other side where it's no longer a problem. So goodbye 49. But if I do it to the left, I must also do it to the right. So now on the right-hand side, I used to have 0, but now I have 49. And on the left-hand side, I now have x squared minus 8x. And I'm going to leave a lot of room right here. And as you do these problems, I suggest you do as well. And you'll see why in just a minute. So x squared minus 8x, pause for emphasis, equals 49. Step 2 is kind of funky here. I know I'm being very rote with the procedure. That's because this is a very hard thing for a lot of students, and I want to break it down to make it a little more simple. Why we're doing this and why it's important and what it physically looks like we will see in class. But right now I want to focus on the procedure. With that said, step 2 is take half of x's coefficient. What is a coefficient? Let me make sure I can spell it right. Coefficient. I think I'm not spelling it right. Coefficient. Take half of x's coefficient. A coefficient is simply a whole number, or a real number, I should say, that is sitting next to a variable. So this right here is the coefficient for x. The coefficient for x squared would just be this 1 that's right here. But we're talking about this coefficient, the coefficient for the x term. So take that number, and this mysterious step 2 on the right here says take half of it. Okay, sure, I'll do that. So I'm going to take half of that. How do you do that? Just take the number and multiply it by 1/2. Why? I don't know, we'll see. That's what the instructions say at the moment. And then what does that produce? That produces a -4. Okay, not sure what I'm going to do with that. Step 3. Step 3 says square the result and then add it back in. Square the result and add it back in. Well, what's the result? Well, this new -4 was just created from -8. We're now going to take that result and we're going to square it. What is -4 squared? Well, -4 times -4 gives you a negative times a negative is a positive. 4 times 4 is 16. And I'm going to do that in a different color. I'm going to use an electric green here. We're adding 16, positive 16. But that's a new introduction into the problem. I've pulled out of thin air, out of this mess right here, I have made 16. So I can't just change the equation because I feel like it. I have to also add 16 over here to maintain equality, right? So take a look at this little cycle that I've done here. It kind of makes a square, which is kind of cute, I guess. You just go down, and then left, and then up, and you're back to there. So that's where that 16 came from. I'm putting it into the problem. Oops, let me turn my phone off. I'm putting it into the problem. So that's why I have to do it to both sides, so that I maintain equality. The 16 is my contribution, so I need to make sure that both sides get it equally. So the right-hand side of this equation just simplifies, and it's fairly simple. 49 plus 16, well, that's just 65. And it's the left-hand side of the equation that's a little more interesting now. So I'm gonna make this all in one color here, just so it looks sort of uniform. X squared minus 8x plus 16. Remember, we started back here at this line, At this line, we could not factor this thing. There are no numbers that go into 49 that miraculously make negative 8, right? But now that we have transformed this thing by producing this 16, which I didn't write very well, we can now factor this thing. Can you think of two numbers that make 16 by multiplication, but that when you combine them, give you negative 8? Well, if you can't, there's a method that some people like to use. It's sort of like an X method, I think some people call it, or X factor or something, where you kind of factor the numbers, 16, and then check to see if they make 8, or sorry, negative 8 down below. So what are some numbers that give me 16? Well, 2 and 8 gives me 16. Do 2 and 8 give me negative 8 when I add them or subtract them? Well, 2 and 8 gives me 10, or if I subtract them I get 6, and neither of them is good. So no bueno there. 1 and 16, no good. Well, what about 4 and 4? 4 times 4 is certainly negative 16, but 4 plus 4 is not negative 8, it's just 8. What if I make them both negative? Don't negative 4 and negative 4 give me 16? And doesn't negative 4 minus 4 give me negative 8? So now I know how to factor this thing. And if you factored a different method, that's perfectly fine. This is just one method you may have remembered. And that's going to be this. And you could distribute or expand, whatever you call it, some people call it FOIL, to turn that back into it. And you'll see that the previous step, x squared minus 8x plus 16, will indeed become x minus 4 times x minus 4. Now a little cheat here to help you out. I don't normally like to give you math tricks, but we'll just save you some time. This number here is always going to be that number right there. That's one reason that it worked. So if you're stuck for factoring, you can just go back to that step. Anyway, well, x minus 4 times x minus 4, well, I'm running out of room here, so I'm just going to save some space. That's x minus 4 quantity squared equals 65. Now, in algebra, you go further. The question actually says to solve this thing, right? Find x equals whatever and x equals whatever. And that's perfectly fine and well, but I'm not going to finish this problem because I don't want this video to go too long, but also because for our purposes, this is as far as we need to remember how to go. From here, we will take it a different direction. So I want to go over these steps before I close the video here. You isolate the x terms, and in the future it'll be the x and the y terms, but isolate your terms that have variables in them. Then take half of the coefficient that's not squared. So that was this negative 8 number back here. What's half of it? It's negative 4. Okay, step 3, square the results. What's negative 4 squared? Well, that's where the 16 was produced. And add it back in, plus 16, but I gotta be fair, so plus 16 on both sides. And then from there it becomes a little bit more familiar to us from algebra. So with all of that said, why are we doing this? It is so, next week, and perhaps after with the EOC coming up, we're going to turn this ugly monstrosity, which is terrifying looking perhaps, into something beautiful, which is the circle. And how that happens is a mathematical mystery we'll investigate next week. See you Monday.